Welcome and thank you for joining. Today's webinar is Intro to Python, Predictive Modeling. The time is currently 12:30 p.m. Eastern. We'll get started in about 5 minutes to give everyone a chance to join and settle in. In the meantime, I'm curious where everyone is joining from. Please share your name and location in chat. This also helps me verify that chat is working in case you have any questions during the webinar. We definitely encourage questions as this helps ensure you're getting the most out of this experience, so feel free to post those under the questions tab next to chat. While you're doing that, I'm going to cover some brief housekeeping items. I've posted some helpful tips for troubleshooting technical issues. You can find that in the very beginning of the chat. If you have any issues with audio or video during our session, please let me know. A couple of quick troubleshooting steps you can take are refreshing your browser, exiting and re-entering the webinar, joining from a Chrome incognito window, and closing any programs you're not using to free up resources. I'm also going to post a survey link. Post that now. It's not mandatory, but it helps us make sure we're continuing to provide quality content. And finally, I've posted a few polls. Again, not mandatory, but it is helpful for me to tailor the pace of the presentation. You can find those under the polls tab, which is right next to the questions tab. So we've got questions like, what is your level of coding experience? What brought you to the webinar today? And how you heard about us. Welcome, Michael from Atlanta and Vishal from Boston. And apologies in advance if I mispronounce anyone's names. Mandy from Los Angeles. So a little bit about me. I'm a data science consultant based out of Phoenix. I've done analysis in real estate, in politics, in AI security implementation, and I'm looking to start doing some analysis in the telecoms industry. I've been working with a potential client on that to help him predict where some 5G radios are going to go. So a lot of interesting open doors in data science. Tell me a little bit about yourselves. What interested you in data science or Python? Just kind of some of the reasons that interested you in joining us today. And while you guys are doing that, we still have a couple more minutes. So go ahead and join or connect to these slides here. I'll repaste that in the chat. Welcome, Josh. So if you follow this link here, it will bring you to a version of these slides you can study a little bit later. And in the slides, it also contains a link for you to get to this Google Colab notebook. This is a Google-hosted Python notebook that is very, very convenient for learning and kind of sharing ideas and exploring ideas. Everything's laid out very linearly. We'll get into how you can get a copy of this a little later, but for now, just go ahead and connect to these and know that as we go through this, you'll be getting a few resources once we're done. So, of course, the slides are one of those. The Colab notebook is another, and you'll also get a download link for the webinar, which will also replay immediately when the webinar is finished. So if you'd like to stick around and get another review of the webinar, maybe follow through the slides again and play around in the Colab notebook, I definitely encourage that. And if you don't have time for that, like I mentioned, you'll get an email link with the download for this webinar. Michael says he wants to learn something new and challenging, and data science is definitely both of those things. So you've made a good choice. It's kind of an exciting industry right now because these tools are very powerful, and now they're very, very accessible. So anyone can, kind of take advantage of a lot of the resources out there to learn, and you can be playing around with these tools and doing useful things with them very, very quickly. And it definitely will challenge you insofar as just, learning and understanding how large amounts of data, behaves and what kind of insights you can get from it. What kind of mistakes can be made. There's a lot of easy ways to lie to yourself with statistics, and data science is definitely not immune to that. So having a good understanding of the core concepts and the foundations is very, very important. But that's kind of what attracted me to it. It is a very, very challenging domain, and it's very easy to take pretty much anywhere. All right, so about 6 minutes after, so we'll go ahead and get started. Again, for anyone who's joined us, we have some technical troubleshooting steps in the very beginning of the chat. You'll also find a link to today's slide deck, so go ahead and follow that. And again, for those who have just joined, a little bit about myself. My name is Mark. I'm a data science consultant out of Phoenix. What brought me here today is kind of the desire to share access to these tools and give people the ability to learn how to manage and handle the ever-increasing amount of data that is kind of being generated about everyone's lives, and use that for positive things. And my programming experience is about a little more than 8 years in Python. I've got some experience with JavaScript, HTML, CSS. I'm not proficient in it. It still takes me a lot of research if I had to engineer something in it. But as a data scientist, you tend to do a lot of web scraping. So being able to at least read and understand what JavaScript, HTML, and CSS are is definitely a good thing. And if you're interested in picking up some of those skills, I recommend checking out some of our web dev webinars as well. You can get information about those on Thinkful's website. And for those of you not familiar with Thinkful, we're a school who train web developers, data scientists, data analysts, and product designers. We do this using one-on-one mentorship and project-based learning. We consider those two things to be the backbone of our learning platform. So with the mentorship, every student is paired with a mentor throughout the entire program. You'll be able to rely on them to get feedback on how you're progressing through the curriculum. They can help you where you're stuck. They can give you advice on your projects or the field in general. And of course, you also have the project-based side of it, which will have you graduate with a portfolio of 6 to 7 projects that you have built from scratch. So you'll be prepared to begin your job search right away. This is very important because Thinkful actually guarantees you'll land a full-time job in the data science field within 6 months of graduation, where you get a full refund of your entire tuition. We'll leave some room at the end to answer any questions you have about Thinkful. But for now, we'll address some of these statements. So Ari from Atlanta, welcome. Thank you for joining. And he says he's curious about predictive modeling and want to get an introductory session on it. This should be perfect for you. Hopefully you'll find it useful. And Mandy mentions that it's interesting and it's a growing field, and both of those are very true. So tonight, this is kind of an outline of what we'll be doing. Again, it's kind of all learn by doing. We'll have this little Python environment that Google is kind enough to host for us. We'll go over a tutorial for that if you aren't familiar, so no worries. But the good news is you won't need to install anything to participate in today's webinar. This is all browser-based. So tonight we'll be covering what a data scientist is, what Python is, and how we use this in real-world projects. And then, of course, we'll give you a few resources where you can learn more. So data science is basically the intersection between the disciplines of statistics, mathematics, and computer science. Computers and software allow us to explore and statistically analyze data much more efficiently than doing it by hand. So we're able to gather vastly more complicated insights than we ever would have without computers. Josh Wills tweeted this kind of tongue-in-cheek definition of a data scientist, and it's a person who's better at statistics than any software engineer, and better at software engineering than any statistician. So we'll be looking at a case study to kind of show you the process of applying data science. We'll be looking at LinkedIn. We're looking at LinkedIn in 2006. They were kind of one of the first companies to bring on a data scientist to improve their website. And they really only began by just kind of taking your email contacts, importing them into your profile, you're really only being connected with people you already knew, and it kind of felt like a giant digital Rolodex. And it was very similar to kind of attending an underwhelming networking conference or meetup in your industry. No one really talks to anyone new and just kind of hovers around the people that they know. And this is essentially what LinkedIn was like in 2006. And this is a quote from a LinkedIn manager around that time in June. And they said LinkedIn was like arriving at a conference reception, realizing you don't know anyone, so you just stand in the corner sipping a drink, and you probably leave early. So they were kind of having a hard time, finding a niche for being useful to their users. And that started to change when Jonathan Goldman was brought on. He was brought on that same year in 2006. They had a pretty respectable 8 million users at that point. I think users kind of saw the inherent value, but the product design wasn't quite there yet. But within 10 years, Jonathan Goldman was going to be able to use data science to increase their user base to about 450 million users by 2016. So he started experiments to predict people's networks. And because LinkedIn was founded by some of the same people behind PayPal, they understood the importance of data, and they gave him permission to circumvent the engineering team, kind of despite the engineering team's initial objections. So the kind of the general process of data science is essentially this. So you kind of want to frame the question. You want to have an understanding of what it is you want to find out. What are you trying to learn, or what are you trying to know? Then you want to collect the raw data and process it, explore it, and then finally communicate your results. The communication aspect of data science is probably one of the more important aspects of it. Because you can do all kinds of analysis, you can look at all kinds of data, and it's really good for you to have those insights for yourself. But the way that you really influence change or improve things, or give a company vision or direction, or a client, or even yourself, your friends, is being able to show other people who are not data scientists, who don't have a stats and math background, who aren't going to spend hours and hours and hours in front of a computer sifting through lots and lots of data. You want to be able to show them the meaning that you found. You can kind of think of it as, you're kind of a filter, right? You take in all this data as a data scientist, you clean it up, you understand it, you analyze it, you become very familiar with that data set, and then you want to show kind of the most important lenses of how to look at that data to other people, so that they can have accurate insights just as you do. So what questions do we want to answer? So let's say you're a LinkedIn data scientist in 2006. What are some of the questions you might have asked to improve the service? I'll give you guys about 30 seconds to think of that, and here's some hints here. So you kind of want to think of things in terms of who, what, where, when, and why, and how. So what specific questions would you be curious about? Would you want answers to if you were in charge of improving LinkedIn service? So I'll give you about 30 seconds starting now. About 15 seconds left. All right. So some of the questions. Okay, so Josh said, why should users pay for a premium subscription? That's a great question. It's one of the things that I kind of find interesting about modern internet services. We've kind of gone from this very decentralized internet, where in the early days, people were really only hosting their own websites, and they were bearing the costs of their own hosting services, to everyone's relying on companies like Facebook or Google or Amazon or LinkedIn to host these services. And it's been very difficult for companies like Reddit, like Facebook, like LinkedIn, to figure out how to monetize to keep the servers running, right? And so part of that is figuring out, what additional information can we provide our users that it would be worth paying for, without really kind of altering or changing the free model that we've provided to them. Ari suggests who would use it, the main reasons why they would use it. Those are also great questions. Thank you guys for your participation. And yeah, basically LinkedIn is all about connections, right? Their tagline is, it's not what you know, it's who you know, right? So how would LinkedIn want to engage their users more? How do we get people using the site more? How do we get more connections? How do we do those things? So exactly, you guys are right on point with those. So the kinds of questions that Jonathan was considering at the time was, what connections, type, and number lead to higher user engagement? Which connections do people want to make but are currently limited from making? And how might we predict these types of connections with limited data from the user? And one of the things you guys will all notice is that all of these things involve sources of information and destinations of information, and who is involved in kind of producing or receiving that information. And that's kind of, gets down to what data science is all about. Everything that humans do, whether that data is gathered or not, everything we do generates information. Everything from the brands you buy and you support and you use, to what geography you live in, to what your job and your career and your economic activity is like, to what kind of media and entertainment you consume, and all of those things generate information when you participate in them. And kind of modern internet services companies like LinkedIn, they want to try and figure out what to do with that data to get your attention, to get your interest, to use their platform. And so a lot of these questions are based around that. So what data do we need to answer these questions? So, of course, we're going to look at connection data. So who is who connected to? We'll look at demographic data. So what is the profile of the connection? And we'll look at some engagement data. So how are they using the site? Exactly what you guys mentioned. So next in the kind of data science process is how we're cleaning up the data, how we're processing it. This can also be called pre-processing or data wrangling. So we want to think about some of the ways that data can be dirty and how we can clean it. So again, the context here is LinkedIn in 2006. Profiles were just a bunch of text boxes for a person's companies, job titles, education, a summary section. So again, very limited. So I'll give you guys another 30 seconds or so to think about, what would be some data that could be problematic for you to work with? What are some minor things that humans could do that you would think would make data dirty and that would need attention for you to clean it up? So I'll give you 30 seconds to think about that, starting now. About 15 seconds. So what is meant by dirty data is kind of, you can think of it as data that would be more noise than signal, right? It's something that would impede your analysis. Ari suggests not having titles or dates. So yeah, missing information. That's definitely, if you've got rows of entries that are missing data. Gustavo suggests misspellings, miscategorizations, empty values, etc. Exactly. These are all great examples of dirty data. And some more or a little more detailed would be like inflated details. Maybe someone kind of over exaggerates their experience in their profile. Not exactly true, but hard to detect, or maybe even it's just outright phony. You have kind of like practical jokes. Maybe someone is claiming to be the president or the Queen of England, or whatever. So you've got kind of like phony job titles. You've got redundancies. Maybe someone signs up for a profile under their work email, and then later they decide they really like the site, and they then sign up with their personal email. You've kind of got to be able to know that that's the same person, right? The whole idea is that the map is not the territory. So you could think you have more users than you actually do. And if you don't have a way of handling multi-identity data and kind of clean that up, it can skew your models and give you less than optimal or less than accurate results. You've also got to think about kind of, let's see here. So different formatting for titles, maybe things are slightly different. You could have someone who describes themselves as like a quote, full stack developer, or someone who describes themselves as like a full stack developer. Maybe there's like a separation of terms in their job title, or they could just call themselves a JavaScript developer. You kind of have to learn how to figure out what, that those things are roughly the same thing. You also have data decay. There's a constancy of change. So data sets can become inaccurate or out of date over time, and inaccuracies can compound in some cases and increase the decay rate. You have any changes to the data structure or any features. So anytime you change these things, that previous data set, almost you kind of want it to be separate and now a retired data set. And once you've changed how your users interact with your site, the new data you will collect is going to be fundamentally different than your prior data. You don't want to kind of like start gathering data and then make a bunch of changes and then keep gathering that data, because the lack of consistency throughout is going to cause your model to be skewed. So yeah, these are great contributions. Again, I appreciate that. But basically, to sum this up, processing is the act of cleaning up the relevant data, reconciling any inconsistencies, any dirty data, and then discarding that irrelevant data. So next, kind of have our data all processed. We can dig in and explore meaningful patterns and draw out interesting insights. So I'll give you guys another 30 seconds or so to think about what the patterns are that they likely found to help them answer their questions. So what kind of patterns do you think they saw? This one's a little tougher of a question, especially if you don't have any kind of math or statistical background. So don't feel bad if you don't have any suggestions for this one, but I kind of want to see what your intuitions are. So no bad guesses here. So I'll give you about 30 seconds to think about that starting now. About 15 seconds. I'll give you guys a couple of hints. So how does LinkedIn kind of identify influencers now, and how do you think LinkedIn suggests new connections for you now? Ari suggests if job titles such as data scientist, business analyst, etc., is the same job type. Yeah, exactly. So kind of one of the patterns is that people are in similar industries. Those people may be interested in connecting with each other. And Gustavo suggests connections versus relevance of the connection. You might need to give me a little more information on that. Let's see. Connections versus relevance of the connection. Okay, so I think what you're saying is basically like you don't want to just suggest just anybody. You don't want to like kind of blast someone with your whole user base as a suggested connection. You want to be able to have some way of paring down meaningful connections for them, connections that they're going to have some greater than random probability that they'll actually want to connect with that person. I think that's what you're saying. If that's incorrect, please feel free to add some more context. Yeah, exactly. And then Josh says possibly capturing the actual links a user clicks when they log in and take that information to gauge focal areas of improvement. Yeah, exactly. This kind of gets back to engagement data. What are they doing on the site? And more specifically, who are they seeking out? Who are they connecting with? And that can also, face you an engineering challenge whereby, maybe your site doesn't have features where other users can go find other users, like with LinkedIn, you just kind of import your contact list and that's kind of what you have, right? So what Jonathan had found through his research was a triangle closing algorithm. Also looking at time overlaps, like who is on the site at the same time, and geographic overlap. So who's in the same city, who's sharing the same geography. And oops. And also, so the way that triangle closing works, just to go into a little more in depth on that. So person A and person B are connected, person B and person C are connected. You can suggest person C and person A connect with each other, and that'll kind of, give you, a better idea that these people are related in some way, right? So now you've got this data of people who have uploaded all their email contacts. So now you have a list of unique email contacts and who those contacts are associated with. So you can look at what users have similar contacts and then find the contacts that they don't have in common, and you can suggest those. And that's essentially what triangle closing is. That alone resulted in a 10 times increase in connections. And like some of the suggestions you guys made, you can weight connections based on, geography, who works in the same city. If they have similar titles, users who have some number of mutual connections with each other, users who obtain similar degrees, and maybe, who went to school at the same time, or, went to the same school at the same time. So there's kind of a lot of different ways you can look at the data to see how people relate. And these usually strongly indicate that these connections would be good suggestions to make to your users. So data scientists will then incorporate those findings from the data exploration to build a predictive model to automate those predictions, right? And that's kind of what, you get into the area of machine learning and AI. You want to, you've kind of done all the manual work, and now you want a model that you can feed new information into, and your model will kind of almost self-program. It'll update itself based on new information, just kind of like how a person learns, right? You go out into the world, you experience new information, and that adjusts how you see the world. It's a very, very similar process with data scientists. This type of predictive model, the one we've kind of been discussing, is a recommendation engine. And at LinkedIn, they called this their connection suggestion algorithm. And this is how users were able to find more connections without much work, right? The whole idea is you want to make the flow of information as quick and inexpensive for your users as possible, and inexpensive in terms of time, in terms of money, in terms of attention. You kind of want to get information moving as fast as it can move. So does anyone have any guesses on what the resulting product feature of this work was, and what LinkedIn product feature came out of this example workflow we've been talking about? I'll give you guys about 15 seconds to think about that. But does anyone have a suggestion? About 5 seconds left. Kind of, and maybe the answer will clarify the question a little bit. So basically, the feature that they ended up engineering from Jonathan's research is the people you may know feature. And this is kind of a great example of data science done right. You kind of have access to all this data. It's very complicated, even a bit overwhelming, but you want to find some elegant way of generating more user activity, right? And there's something that happens when a person recognizes someone else, right? Imagine being out in public, you weren't expecting to, but you bumped into somebody you went to high school with, or, you bumped into a former colleague or something like that. There's something that happens there psychologically, like, oh, I know that person. And, you want to connect with them. And LinkedIn makes that very easy with this feature, right? And so now all of the information that LinkedIn has about you and your connections, they don't just have the view of you and your connections. They have kind of that, 65,000 foot view of everyone and everyone's connections. So not only can they see who you're already connected with, but they can see everybody that all the people that you're connected with are also connected with, and they can use that to very easily and quickly make recommendations for you to connect more with their community. And yeah, Ari mentions, basically making more meaningful connections. That's absolutely correct. The more you recognize people, the more you connect with people, the more the more useful the LinkedIn network can be. You can almost kind of think of it as like a positive network externality, right? An analog example of this would be, way back when phones were first existed, first invented, if you were the only person who had a telephone, it wasn't a very useful device because by its nature, it's a connection device, right? But second phone makes the first phone a little more valuable, and the third phone makes all three of those phones a little more valuable, and so on and so forth. So same kind of idea. The more people you're connected to on LinkedIn, the more information it's going to return to you based on posts and what other people are doing and what they're interested in and what's going on in your field and what's trending. And being able to connect to that, every additional LinkedIn connection that you take on is a more opportunity for you to get information and find use of LinkedIn, but it also gives LinkedIn more data. The more connections you make, the more data that they have, and the more that model can be useful to them as well. And Ari says the data is clean and they can build products based on this good data. Yeah, exactly. It takes a lot of pre-processing, a lot of work to get to something that's even this so seemingly simple and elegant, right? This is kind of one of those things that anyone could look at and be like, oh yeah, that's obvious. But it can be very easy to take for granted that in 2006, kind of on the cusp of all of these things, this wasn't obvious, and this wasn't something that someone just came up with after just kind of sitting down and thinking about it. They had to put a lot of time and effort and data science into arriving at this very elegant feature of the site. So you have all your data, it's all nice and processed, analyzed, and you have a way to help users make more and better connections. Now you need to tell the rest of the company what you found so they can support the implementation of these suggestions. So how do you communicate your results? Ideally, you'll kind of get as much attention as you can, but there are some benefits to defining your audience and delivering the message that will resonate with them, right? You can kind of you can share it with everybody in the company and see who's interested and try to get support that way. But typically, it's a little better to kind of take more of a nuanced approach. You kind of want to separate your company out into who could find these results useful inside the company. So you can think of it from a marketing perspective. You might want to take the approach of maybe something like, hey, this could lead to more impressions on a page every hour. That could mean more ad revenue. You can take a product perspective approach. So, we might want to build these features or those features to help users close relational triangles to find each other. You can think of it in terms of approaching the development team. You might want to be able to gather data to show, how long a new feature will take to develop and if additional staff is required. These are all valuable things to consider, of course. And then from a sales perspective, so, you can demonstrate, hey, we can generate more users this way. The more users we have, the more likely they are to upgrade to premium services. The more users we have, the more data we have, the more valuable those premium services will be. So the overall result of implementing data science to LinkedIn's data sets was a jump from 8 million to 450 million users in 10 years. So that covers the data science aspect from a high-level perspective. Before we move on, do you guys have any questions about kind of data science and the process that you'd like me to answer now before we move on to Python? I'll give you guys about 15 seconds to think about that. Starting now. All right. So yeah, Ari, did you have a question, or were you just being enthusiastic? Let me know if you need a little more time. Okay, cool. Okay, so yeah, no questions on the data science aspect. And of course, I will be hanging out in chat after the webinar ends. So if you guys, want to kind of go through this part of it, if you have any questions that come up, feel free to jot a note down. I will be hanging out in chat at the end for about 10 to 15 minutes. And I'll give you guys some contact information on how you can reach me by email if if other questions come up after the webinar. So now we'll cover Python. So Python is a flexible language that's used in several types of programming. So data science, obviously, robotics, web development, automation. It's kind of been a jack of all trade, master of none until data science came along, and I kind of attribute this to the fact that Python is very popular at a lot of these big data companies that have emerged. Google, Facebook, Amazon, Twitter. A lot of these companies are using Python to do back-end analysis, and a lot of those developers have open source projects of their own, and the companies themselves have a lot of open source projects, and this is kind of like what's been responsible for giving a lot of people access to data science tools, and that's where it's really kind of shined. Was with the advent of data science, but you can definitely use Python to explore robotics and web development, automation. All these fields have other things, other languages that you can use. Like a lot of people use, like C or kind of like lower level languages to communicate with, like, say, an Arduino or something like that. Rust is also becoming popular for robotics. Web development usually is going to be kind of, maybe some sort of JavaScript stack. You can do Python development or you can use Python for web development with Django. But I don't know many jobs that will pay you to know Django. Most of the time, if you're doing web dev, they're going to want you to know JavaScript, HTML, CSS type of thing, and then automation. And Python's actually quite good with automation, and that kind of plugs into how it's useful for data science. It's a very quick and intuitive language. There's very minimal syntax, so it's very easy to get ideas out on paper and to get them running and working, even if they may not be the most efficient thing. It's still helpful with being able to move information around. So we'll walk through some of the sample code, and the whole idea here is basically just to give you guys some ideas on jargon or vocabulary, if you will. So I'll go ahead and read through this, and I'll give you guys some time for any questions at the end of the slide. So if any questions come up, feel free to write those down and post them in the questions tab, and I'll kind of address them before we move on. So I think from the polls, let's see. So perfect. So this is going to be a good class for you guys. I can see we got a couple of people in here with no coding experience, and a couple of people with 1 to 6 months of self-teaching. So that's great. This would definitely be the time for questions if they come up. If you don't have any questions by the time we're done with this slide, you will have ample opportunity to ask as we progress. So the first thing I want to kind of point out is the syntax highlighting. So you can kind of see that unlike a normal text document, there's all kinds of different colors and things like that. And you can kind of see how there's a pattern that corresponds. So kind of things that are in quotes are this red color, things that are numbers are this green color, things that are after a hashtag or an octothorpe or a pound sign, whatever you want to call it, are kind of an orange color. And then you have, of course, just black color here, or I guess shades of black or black shade. So what this is basically doing is it's helping you kind of have some amount of information where you can select what it is you're looking at in all of the code, right? So the red color, these are things that are strings. So strings are basically text data that are defined by some pair of quotes, some pair of matching quotes. So you can have single quotes, you can have double quotes, you can even have triple quotes. It doesn't matter which you use as long as they are consistent from start to finish, and that you don't try to use that same type of quote somewhere inside of the string. Because if you were to like put an apostrophe here, it would end the string where that apostrophe appears, and then just start a character that Python doesn't understand. So if you wanted to make this like possessive and say Jane's, you would want to use double quotes here, and then you're free to use the apostrophe S. We'll get into a little more of the rules of that as we get into the notebook, but it's kind of a good primer to have. So the first thing we've done here is we've created a variable called first_name. We are using the equal sign as an assignment operator. So what that means is this is dissimilar from kind of the mathematical equal sign. In Python, what you would want to use for that is a double equal, and that will do a logical test. So if you say, is this double equal to that, it'll tell you true or false as a result of that. But in this case, we're just using it as an assignment operator. And what this will do is assign the string Jane to the variable first underscore name. You can see that we also have last name equals Smith. Last name uses something a little different, a different convention to separate the words in the variable. So what this is for is Python is a white space syntax language. So what that means is white space actually has meaning in terms of how Python understands what you mean by your code. So there are also readability conventions in Python. So one of the things that's really important is you want to be able to accurately name your variables. So you want that variable to sufficiently represent what kind of information it actually represents, right? So you can imagine having a very, very long list of names, and you're piping in variables for first name and last name, and so these variables could be any pair of first name and last name, but you want to be able to categorize those things accurately so that you know this is going to be a first name, you know this is going to be a last name. And the change in convention here is basically to kind of give you some options. So this first convention is called snake case, where you use underscores to separate each of the words. And then the second one is called camel case or type case. And this is to separate words where you basically capitalize the initial letter of each word after the first. You can kind of see that this first one is lowercase. Then we have age, and that's set equal to the integer 34. We have GPA, that's assigned to the float value 3.22. And so kind of strings, integers, and floats, these are what are called data types. And data types you can think of as the primary colors of programming. They kind of generally encapsulate the basic kinds of information you tend to deal with. And there are many, many, many more data types than just strings and integers and floats. You can do complex numbers, you can do lists, there's lists and dictionaries and all that get more into like data structures, but you can have date times. There's all kinds of different data types that you can have in Python, and you can kind of just think of those as having additional primary colors in your toolkit. So then next we'll cover the print function. So the print function, you can kind of see, again, this syntax highlighting here is purple. And another thing to keep in mind is the syntax highlighting can be different in many different IDEs. And IDE means an integrated development environment. So it's kind of what's going to give you your terminal, your place to put your code, place to run, test, and do all those kinds of things. And in our case, we'll be using Google Colab as our IDE. But yeah, the syntax highlighting can be different from a development environment to a development environment. But the thing you'll notice is that they're all just basically commonly highlighted. So all the functions are going to basically be purple in this example, so you know what you're looking at. So the print method allows you to do a whole array of different things. So for instance, we can concatenate values of variables by typing out the variable name and then using the addition sign. We can even place just unvariabled strings. So in this case, we're just placing a space that's defined as a string, and we're concatenating that in between the first name and the last name, so that when we print it, what Python does is it kind of unpacks this first variable as Jane. That connects a space. It kind of appends a space to the end of that, and then it unpacks the second variable, last name Smith, and then now you're getting returned just Jane space Smith. If you were to just concatenate with the plus sign between first name and last name, and you were to kind of leave off this part here, what you would get is Jane Smith, but it'd be kind of crammed together. You can also do math inside of the print function, so you can evaluate multiplication, addition, subtraction, division, and in this case we're taking the value of age, which is the integer 34, and then we're multiplying it by 2, and it's printing out the value 68. I mentioned data structures a little earlier, so this is an example of one of them. This is a list. In Python, lists are arrays of ordered, mutable data. So what that means is ordered means, when you place this in the kind of 0th index, lists are indexed by 0, by the way, meaning that the first element is actually the 0th element. So whatever you place for the 0th element is going to stay in the 0th element. Whatever you place for the 1st element is going to be in the 1st element, so on and so forth. So these will not change order, and you can reliably recall them by index. And each value is going to be separated by a comma. And we define lists in Python by using square brackets. Now, you got to be careful because square brackets don't always mean a list in Python. There are some uses of square brackets that are syntactically different than that. But most of the time, if you're dealing with square brackets, you're going to be dealing with lists. And mutable means that you can update these values so that you can later refer to this index from this variable, so prices, and maybe this gets updated, right? Maybe the price changed. Maybe you had a vendor increase or decrease the price of a product, say, and now you need to update that value and reflect that. You can do that with a list. And you're not limited in only having the same data type in that list. You can have a float, you can have a string, you can have an integer, you can have another list, you can have a dictionary, you can, any valid object in Python you can put as an item in a list, which gives it a lot of usefulness. So just like we did with our other variables, we've got our prices variable. We're using our assignment operator. We're giving it the square bracket notation, start and end, just kind of like with a string. You want to make sure that you have a pair of them and that they're corresponding and they match. So you have the opening square bracket and the closing square bracket. And then you have your values separated by comma. And now that is stored in prices. And we'll learn a little bit more on how to address indexes in the list when we get to our notebook. Then we have some comments here. So Pandas syntax and empty data frame. So this kind of covers one of the tools we'll be using tonight, which is Pandas. And Pandas is a tool that allows you to deal with a lot of relational data. You can kind of think of it as like an Excel spreadsheet, like, one layer of abstraction further removed. But if you kind of think of it in terms of you have a header, you have rows, you have columns, and the intersections of those rows and columns are kind of where you find your meaning. That's a good way to think about it. So like our other variables, we're creating a variable, df. In this case, it stands for data frame. This is kind of a generic convention that you'll find in the Pandas documentation of how to create a generic data frame. And in this case, we're creating an empty data frame by assigning df the output of pd.dataframe. We'll get into a little more of the syntax here, but for now, just understand that when you run this, it's almost kind of like opening up opening up Excel and starting a new worksheet. It's just kind of blank. There's nothing in it, but now you can kind of add information to it or manipulate it or do what you're going to do with it. And in this case, so we've created our new data frame and we want to assign it a new column. So we'll pass it the column name as a string, and then we'll set that column equal to the data that we want it to represent. So in this case, you can kind of think of this as, in Excel, you start a column and then you pipe in some data, you call it column name. In this case, maybe a better name for column name here would be prices, and then you set it equal to your list of prices. So now you've kind of transposed this from being a list that runs horizontally. Mentally, you can think about that as now it's just like a column in Excel. So you have 23.8, then 99 cents, and 75 cents, and 14.98 cents, and that's kind of your column. And you can select multiple columns. I'm waiting for that to go away. There we go. So you kind of have df column 1, comma column 2. And like I mentioned with the, this wanting to be careful with the square brackets. So just I'll unpack this a little more when we get to the golf predictions, because it's kind of, this thing here blocks some stuff off, and it'll be a little easier to show. Gustavo asks, is Panda built into the IDE or is it something that you call? So it's built in for this IDE. If you wanted to do it locally, you'd have to install it. I can I can show you some syntax for that towards the end. Just remind me towards the end when I'm kind of hanging out in chat. And then you also ask, it also is pd.dataframe something that is already defined in Pandas. So yeah, you're basically, so PD is a shortening alias, and we'll get into that when we get into the Colab notebook. So I'll address both of these once we get in there. So let's see here. So predictive modeling is kind of really what sets data science apart from data analysis. For the LinkedIn example, they found the patterns in the types of connections people were making to create higher engagement. So they started suggesting similar types of connections. That's essentially predictive modeling. Is how do we predict that a connection is going to be similar? And in general, predictive modeling takes what we know already happened in the past to help make decisions for the future. You can also do this in reverse. So for instance, let's say you have very limited information about a past event, and you can do some analysis, and maybe that will get you more information about that past event, and maybe enough information to kind of predict what happened in the past, almost, kind of forensically. And then you also have classifications. So, being able to classify, maybe giving computer an image and say, classify all the objects in this image, or classify this as a unique face, or a face that's already in a database. So these are kind of some of the general, functions of data science. But in general, when we're exploring the data, you can find what predictors, also known as variables or features in data science, might help make these predictions. You can feed those into a model that will make a prediction about what will happen. This is also called training. And a model can be as simple as a linear equation where you have your x's as inputs, and the model, or in a linear equation, the line will kind of predict your y values. And not all models are this simple, and they can tend to get very complex. So different models are useful for different data sets, questions, and business applications. We don't have time to go into all types of models today or reasons to use them, but those are great topics for continuing to learn. So I'll provide some resources for you to continue learning a little later. But the model we'll be using today is a decision tree. And you can kind of see, some of the other models are k-nearest neighbors and neural networks. But today we'll be covering decision trees. So the question we're going to be attempting to answer, so the first part of it is we want to kind of frame our question. We're going to look at some weather data. It's fictional weather data, and it's pretty limited, but it's a good place to start because it's going to kind of show you it'll give you a scaffold. It'll introduce you to the tools that you'll be using to deal with that data, with information that's, a data set that's small enough that you can kind of wrap your head around it when you study it a little later. But the question we're going to ask is, should we play golf or not? The data that we have is information from 14 previous days. So this is going to be the weather conditions, and then we also know whether or not we played golf on that specific day. And our goal is to use that data from the past to build a predictive model to help us make better future decisions. So in theory, what we'll be able to do is say, given this past data, and whether we played on that particular day or not, so given our conditions and given whether we played in those conditions, we can put in information about the current condition or new conditions and make a decision of whether we should play golf or not. So as mentioned, our model is going to be a decision tree, and the decision tree predicts the most likely outcome based on input. And it's essentially like building a computer version of 20 questions. So we want to distill that down into a bunch of yes or no questions, and it's a little easier to visualize kind of the usefulness of decision trees comparing it to a table. So you can see here in a table, if we wanted to go through this data and say, whether we should play or not. So let's say today is kind of rainy, the temperature is mild, and the humidity is high, and it's not windy. We kind of have to go through and say, okay, well, let's look at all the, we know the outlook is rainy, so we kind of have to know that we're looking at these. And then we know the temperature is mild, so it could be this one, or it could be this one, or it could be this one. We know the humidity is high, so it could be this one or this one. And you could see there's just a lot of iterative, and you kind of have to think about every line to kind of get to your answer of, okay, yeah, we did play golf on that day, and since we have similar conditions, we'll play today as well. Decision trees are not only more efficient for humans to interpret, but they're also more efficient for computers to interpret, because instead of having to, take clock cycles to go through and iteratively check, each one of these, whether it's rainy, and then check the ones that are left and, go through that whole process, computers can just say, okay, let's ask what the outlook is. The outlook was rainy. Perfect. Now we've snipped off two whole other branches of the tree that we now don't have to waste any clock cycles or any thought on. We can just proceed down to our next question. Okay, was it windy that day? Yeah, it was. The wind was a little weak, and we can kind of go through that and arrive at our answer with far fewer attempts at trying to figure out what that data is. So this is the link for our Colab notebook. I'll go ahead and post this in the chat. And as mentioned, you will have access to this with the slides link. This is kind of your way to get the master copy. And when you click on this, it will open up this new tab, and you'll notice that you can't actually run anything. Oops. Actually, I may be able to run this because I have editing rights, but if you guys try to run this, it probably will give you an error that pops up down here that says that you can't. So what we want to do to get you your own copy is in the upper left here by the Colab logo and the Google Drive logo, you'll see File, and what you want to do is save a copy and drive, and that option is going to be about halfway down. So File, Save a copy and drive. It'll tell you it's creating a new copy, and after a couple seconds, it will open a new tab, and you will now be able to edit this. It'll say copy of golf predictions, and now you can see that you can edit things and run things. A couple of quick notes on Colab. So just a quick tutorial and some information about it. So Colab is a version of Linux that Google is hosting. It's like a virtual machine. And what's unique about this version of Linux that's running in this VM is that it's essentially optimized to run Python. If you're into Linux, or like you kind of know what Linux is, it's essentially an operating system similar to Microsoft Windows or Apple Mac OS, but Linux is free and open source, so you don't have to pay any licensing to use it. And it kind of gives you the whole file structure here. If you're familiar with Windows, this is essentially like your C drive. If you're familiar with Mac, this may look familiar to you as well. You might see things like, having a library and things like that, but it'll be slightly different. You can connect your drive to it, so any data you have in there, you can connect. So maybe you have CSV files you want to analyze, you can connect those to the environment. And we're in the content folder, and we've got some sample data here. So we've kind of got a very common housing data set for California that was actually generated by, I believe, the 1990 census. And then you have the MNIST data as well. And MNIST is a set of handwritten numbers that was also generated by the census. And these are two common kind of data sets for learning, machine learning. We won't get into these today, but we do have some other webinars that cover the California housing data. If you're interested, you can check Thinkful's website for that. You can also upload data to this. So if you have a CSV locally, all that, you can kind of, you can add data to this, and you can start playing around with that. So that's kind of the Linux side of this. So you have your interface here in your integrated development environment, and there's two kinds of code blocks you have. So you have text blocks and you have code blocks. You can add new ones with either of these buttons, and you have some controls whenever you are inside. So when you click on a text box, you can see, you can kind of change the position, you can link to that cell, you can add comments, you can edit it, you can throw it away, you can copy it, stuff like that. We'll go ahead and throw this one away since it's an example. So today we're going to be testing our decision tree model in this notebook to predict whether or not we should play golf. That's kind of our big question that we formed. And you'll need to add some code to complete this notebook. So anywhere you see this kind of triple asterisk with these capital letters, add code here, that's going to be an opportunity for you to live code. So to execute a line of line or a block of code, you'll simply hit the play button on the left side using the key, or you can use the keyboard shortcut Shift Enter, and then that code block will execute. If you run this, you'll notice you'll get an error. And the kind of error you'll get is a syntax error, and it'll tell you that it's invalid syntax. And the reason for this is that we have our variable x, we're using our assignment operator equal, and Python doesn't know what to do with this. And that's because there are no legal objects that begin with an asterisk in Python. So what we'll do is we'll kind of make this a string, and this will kind of be, I'm just going to change this to hello world, because that's a very common thing to start when you're learning a new language. So I'll go ahead and run this now. And basically, like our previous slides, what we've done is we've assigned a string, hello, excuse me, we've assigned a string to our, we've assigned the string hello world to our variable x, and then we're using the print function to print that out. And you can see now that we have that returned to the IDE. Let's see here. So the next thing that we're going to do is we'll just kind of read through our comments here. So we're going to import the appropriate packages. So packages, also known as libraries in Python, are essentially pieces of code that have been written and optimized to the best standards so that it spares you the effort of having to kind of reinvent the wheel every time you want to refer to that. So some of the libraries we're going to be dealing with today are sklearn and pandas. You've kind of already seen pandas, and we'll get into a little more of what sklearn is, but for now just kind of understand that it's a package that we use to kind of like analyze data mathematically. And so what we'll do is I'll give you guys about 30 seconds to add this code here into where it says add code here. And what you'll want to do is you'll want to copy this entirely and delete it, and then type out these two things here: from sklearn import tree, import pandas as PD. You want to make sure that the syntax highlighting, whatever the color is, the things that are being highlighted, you want to make sure that those match up in here. So I'm going to go ahead and drag my Colab away, and I'll give you guys 30 seconds starting now. About 15 seconds. All right. So go ahead and drag this back. If you haven't finished typing it yet, no worries. I'll kind of go through this code to give you some time to catch up. So we've imported the appropriate packages. So we've imported sklearn from, or we've imported tree from sklearn. So from sklearn import tree is the syntax that allows you to select just a specific component of a library. You don't have to import the entire library. And sometimes you don't, sometimes you would want to use this if maybe you have limited resources. So for example, here in Google Colab, you can see that there's a counter for RAM and disk usage. And we're using very little RAM and very little disk usage currently. But sometimes your project might necessitate that you run it very limited. So in this case, we want to show you how you would just import those parts of the library that you're interested in. And then, as discussed before, we have an alias here. So we're importing pandas as PD. And again, pandas is the library we use to handle relational data. So it's kind of our abstract, you can kind of visualize it as an Excel spreadsheet. And so we're importing pandas as PD. And the reason why we tend to want to shorten things, as I mentioned before, there's some readability concerns in Python. So as I type through here, you can see that there's this dotted line that gets suggested once you get close. And what that is a PEP8 convention. And for you new programmers out there, this is something I would highly recommend checking out. Let me paste this in the chat for you. So PEP8 is a style guide for Python that gives you guidance on how to write code that other Python developers can read and understand very easily, very quickly. There's some things in here that go over that. I strongly encourage you to check this out, in your own time, or maybe while you're going through this, to see, what conventions would apply to your code. And we can see somewhere in here that discussed line length. I can't find it right now, but basically the reason why you don't want a line to be too long is because the longer it is, the harder it can be to kind of absorb that specific idea. And if you kind of think of a line of code as just a very granular computer science idea that you're trying to express, you want to try and keep them succinct, right? Brevity is the soul of wit. You want to be a good programmer by making your lines very concise. And that ties back into the alias here, because this allows us to shave off some characters, to save some things, save some space, so that you can have very concise, complete ideas in each line of code. There are other conventions that other aliases for other things that you can shorten, and usually you can find that in the documentation for that specific library. If you'd like me to show you how to access things like that towards the end, feel free to ask me when I'm in the chat after the webinar ends. And then this is just a code that's kind of a line of technical convenience for allowing us to display images in line with the Colab notebook. And then the packages for rendering our tree are py.plus and graphviz. So we just import those here. So next we want to collect the data. I'll just go through this in the Colab notebook here. So we're going to load in our weather data and whether or not we played golf. So just like before, we're creating an empty data frame. So PD, again, that PD refers to our pandas library. It's just shortened with an alias. So PD.dataFrame. So we're using the data frame method. We're not passing it any arguments, and we're assigning that to our variable golf_df. So again, we're referring to this df to tell us that this is a data frame, and then we're giving it a name, in snake case, so like kind of an initial word to describe what exactly that data frame represents. So we can look at this and we know that this is representing a data frame of golf data. Then we're going to add our Outlook column. So the way we add a column is just like we did before. We're going to give it square notation right next to the data frame that we created, right next to the variable for the data frame, and then we'll pass it a string of the name of that column that we want. So again, would kind of be like in Excel, where you just kind of give a column a header at the top. So our header will be Outlook, and then we're going to assign that a list of strings that correspond to the Outlook. So whether it was sunny, overcast, rainy, so on and so forth. And again, lists are ordered, so the place that this string occupies will be the place that it continues to occupy unless we change it. And then we add our temperature in the same way. So we have our square bracket notation. We add a string that says temperature. So we now have, you have like your first column Outlook, and it would be sunny, overcast, rainy, etc. And then you have temperature. So the temperature would kind of like be the next column over. You have 92, 86, 83, 50, so on and so forth. And because the index is going to match, because lists are ordered, these indexes will match and they can be related to each other. And this is kind of the relational database, or the relational data set side of things. So we have one column, a second column, and then we have rows that have values that are going to match up. Gustavo asks, so is the data frame indicating a matrix format or something? You can think of it that way. If you kind of take a linear algebra approach, a matrix is a good way to think of these things. You kind of want to be careful there, because matrices are usually related to number data only. But the nice thing about computer science is, you can turn anything into a number. It's all based on binary. So you might have to make some decisions and do some work on how to do that. And that is actually something that data scientists spend a lot of their time doing is, how do we come up with a different representation of the data that's going to work in this model, but still have that representation be accurate. So yeah, you can kind of think of this as a matrix. And then we're going to add our humidity, windy, and then our final column play. And so this This column's a little special. This is going to be our target data, and we'll get into a little more of what that means. But for now, just understand that this is the data of the outlook. These are kind of our inputs, and then this is our output. This is what actually happened that day given those conditions. And all of these things will line up. So you can now imagine you have your row of headers, so outlook, temperature, humidity, windy, and play. And then you have your columns. So one row would be sunny, 92 degrees, 40.3% humidity. It was not windy, and we did not play golf. So we'll go ahead and run this. You shouldn't have to contribute any code to this. It should all be there. But if you get any errors or anything like that, let me know, and we can try and troubleshoot that real quick. But you want to make sure that you run this this play button here, and you'll know that it ran because it'll give you a number of the order in which that cell was run once you take focus off of that cell. And you can see that it goes from like 3 to 5. If I were to run this again and jump out of here, it'll increment again to 6. So this keeps track of the order in which the cell was run. And then we're going to take a look at what our data frame looks like. So this is kind of a good way of visualizing it. So we have our index here. Again, that's going to keep track of a unique value for each row. And because it's 0 indexed, you can tell that we have 14 entries here. So from 0 to 13, including 0, is going to be 14 entries. And then we have our outlook, temperature, humidity, windy, and play. And you can see that each one of these things here match up to the order in which it appears in the list that we used to define each column. Any questions on that before I move on? Any errors, anything like that? Now would be the time to ask. And feel free to type that up while I'm setting up the next slide here. And it's kind of the same data here. You know, we have our target data here, which is our play column, and we've printed the data frame out to make sure that it looks like the data that we put in. We always want to make sure that you know, we double check those things, because it can be very frustrating to it's harder to do it here where you're like kind of hand coding in the data, but a lot of times when you're like importing a CSV or a database or something like that, you always want to make sure you look at you know, your data in some way to verify that you're working on what you're intending to work on. So now that we have our data, we want to be able to run our decision tree model to make our predictions. And before we can put our data through the model, we have an issue. Our data is not numerical, but sklearn trees needs numerical data. So I kind of covered that a little before, where you know, in some models you have to have data in a certain format. And fortunately, we can easily fix this. Again, this is something a lot of data scientists spend their time doing. So you know, we can there's tools to make short work of this. So there's a method called one-hot encoding, and this method uses binary values, so 0 and 1, to recreate a table with new features labeling 0 for false and 1 for true. And Pandas has a function called getDummies that allows us to convert our strings into numerical data in one line of code. We often refer to these encoded variables as dummy variables, since they are placeholders for our original data. So you're going to basically take this code here and apply it to this code block here, and you have your add code here. So you want to make sure that when you remove these, you don't accidentally clip one of your parentheses. But I'll go ahead and give you guys about 30 seconds to type this in there, starting now. About 15 seconds left. All right, no worries if you're not done typing. You'll see the code here, and as like I did previously, I'll go ahead and go through it. So we're using one-hot encoding using Pandas. So we have our variable, in snake case, one-hot data. We're assigning that to the output of this code here, and this code refers to our pandas library, so PD dot get dummies. So our get dummies function in this instance is going to take one argument, and that argument is going to refer to what two categories, what two columns of text data. So we have Outlook and Windy, because we can see that our other two are already in numerical format. Our target is also not numerical, but that's slightly different because that's kind of our output. We won't need to modify that. But right now, all we need to change is our input data into numerical. So we take the input data that relies on strings, and we pass that to get dummies. And as I mentioned before, so this inner set of square brackets are a list. So those square brackets are used to define that list of the columns that we want to convert. And then the outer square brackets are actually syntax that Pandas is using to refer to those two columns. So kind of like when we set our columns up, so golf underscore df humidity, this string passing here, because Pandas did not have a column named humidity, it added it and it assigned these values to it. And then if we want to refer to that later, then we would pass that string to golf underscore df inside of its square brackets. And because we want to refer to multiple columns, we have to pass it as a list. And that's why we have that inner set of square brackets. So basically what we've done now is we've outputted this information to one hot data, and we'll go ahead and print one hot data. I just want to make sure that the pace is going well for everyone. Is 30 seconds a good amount of time for everyone to kind of type this stuff in and run it and make sure that it's there in your notebook? Let me know. I can adjust things if needed. And actually, let me do this. I'm going to add a poll. I'll go ahead and publish this. And the poll is how well you're understanding the topic so far. I'll give you guys about 15 seconds to kind of go through that, read through it, and answer. I'll give you 15 seconds starting now. Oh, and sorry to mention, that's going to be under the polls tab. So you have chat at the top, you have questions, you have polls. Under the polls tab, you'll see how well you are understanding the topic. So go ahead and answer that real quick, and then we'll move on. All right. So yeah, once you run this, what you should get is kind of like what we got out here, but now you can see some differences is instead of just having Outlook and just having Windy, so instead of just having this and this, what the one hot encoding has done, what the get dummies method has done, is it's taken every unique value in Outlook. So we've got overcast, we've got rainy, and we've got sunny. It's taken each of these unique values and it's created its own column. And the output of that column for that row, or the output of those columns for that specific row, so say row 0, it's mutually exclusive for that feature. So we have kind of our Outlook feature, and then we have our Windy feature. And like our Outlook feature, our Windy feature also has unique values, but it only has 2 unique values. So it only needs 2 columns in its get dummies output, whereas Outlook needed 3. So we have Outlook overcast, false for 0, Outlook rainy, false for index 0, and Outlook sunny is true or 1 for index 0. Our Windy is false, and that's a 1 for index 0, and our Windy is true for 0 for index 0. So the way you can kind of think of that, if I can fit both of these on the same screen, is when we look at index 0, we see that the data for Outlook is sunny, and so that is definitely not overcast and definitely not rainy, and that's why sunny gets a 1. And that's kind of why this is called one hot encoding. So one hot encoding is kind of like only one value is hot. The others are going to be 0, and so it's kind of mutually exclusive. And then we can separate that up. So we should only expect to see 2 ones per row of data, and each one of those ones is only going to appear once in its respective attribute of Outlook. And so now you see that we have a whole list, or we have a whole a whole set of new data that we can now analyze because this meets our requirement of being numerical data, and it still accurately represents the data that we have. Any questions on one-hot encoding or dummy variables? Looks like for the most part, people are getting it, but I can definitely slow down and give you guys a little more time to type and ask questions if needed. So feel free to add those in while I'm setting up the next slide here. So this is kind of just going through the same thing that we went through. You have your index, and then you have your one-hot encoded variables for each of those. So the next thing we need to do is join the continuous data with the newly encoded data. So the continuous data kind of refers to, our float values or temperature, stuff like that. And the way we want to do this is using the pandas join method to join the two data frames back together. And then we'll print Gulf one hot data to see the joined data frame. So basically what we're going to do now is we're going to input this code into this code block here. So kind of under the code block where you have the comment joining together the continuous and dummy variables into one data frame. Oh, actually, oh yeah, so this isn't live coding. So I'll just go ahead and run this, and then we'll kind of walk through the code. So we have golf one hot. So that's kind of different than our data frame before. So we have our data frame golf underscore df, and then we have our variable one hot data. And now what we want to do is we want to join our one hot data to the other values in the other numerical values in our data frame. So what we're going to do is create a variable called golf one hot using snake case. We're going to set that equal to the joint of this information, so our numerical data, with our one hot data, and we're going to use the join method to do that. So it's this information dot join, and then our one hot data variable that we created up here that contains all of our ones and zeros. And now when we run that, so when we return our golf one hot, instead of having just temperature, humidity, outlook, and windy, now we have the temperature, which is our numerical values, or humidity, which are also numerical values, and then we have our one hot encoded data, our one hot encoded data now here. So now we have all of our data in numerical format for our model to use, so that we don't have to worry about the strings giving us an error. If you try to run a string through a decision tree, it will give you an error in Python. But now we have all of our original numerical data and our newly numerically encoded categorical data all in one data set. So it's ready for modeling. And so finally our data is clean and usable for our model, and now we can train our model. So note that the kind of anticlimactic part of data science is that training a model and making predictions is as simple as 3 lines of code. Our 5th code block, we will be creating a variable to hold an empty decision tree. So just like we set up our empty data frame, we're going to set up an empty decision tree. And this variable will be called CLF. So we have CLF, and we've assigned it to the value of tree.decisionTree classifier. So now we have our empty decision tree stored in our variable CLF. And then we want to fit our decision tree with inputs and our target. So we create a variable CLF underscore train, and we assign that the value of the output of this code here. So we have CLF, which refers to our empty decision tree classifier, dot fit, and we'll use the fit method, and we'll pass 2 arguments to the fit method. So 2 arguments inside of the parentheses here. So golf underscore one hot and golf underscore df play. So our strictly numerically encoded data frame, and then our target from our original data frame, our target column from our original data frame. And then we'll render that. So we create a variable dot underscore data equals tree.export graph viz. So export graph viz is a method used by the tree from sklearn, and we're going to pass it our CLF train variable. We're not going to create an output file, and then we're getting our feature names from golf1hot.columns. Our class names, so our output, we want it to be no golf or golf, and we want that to be filled in as true. I'll kind of hop over to this side here to go through the rest, since this little very informative box cuts off some of the code. So we have kind of the same code we just discussed here. So this is your opportunity for live coding. I'll give you guys about 45 seconds to do that. And so what you want is you want to take in the data from let's see, CLF train. So you want to take in the code from here, and you want to put that into this code block here that's under the predictive modeling section. So I will give you 45 seconds to do that, starting now. Oops, clean that up. So this is the code that you want to put in. You've got 45 seconds for that. About 30 seconds left. About 10 seconds left. All right. No worries if you're not finished typing it yet. I'll leave this up here while we go through it. So we have our comment, create empty decision tree. So we have CLF, like we discussed before. We have our CLF variable, and that's going to create an empty decision tree for us. Then we want to train our data, so the data being the one hot encoded numerical values that we created, and then our target data. And then we're going to stick those into the fit method as arguments on our CLF, on our empty decision tree, and that's going to return to us a trained classifier with the data that we created. And then we're going to render our tree, so dot_data. We're going to use the graphviz, or export graphviz method to do that. And then our graph is going to equal pi.plus.graph from .data. So we're graphing it from here. We're passing in our .data, and then we're rendering that image as a PNG. And now this can be a little harder to analyze. It doesn't seem as intuitive as kind of the nice clean decision tree we looked at earlier. But this is just a matter of kind of understanding each of these things. So we have our Gini coefficient, and this is a measure of similarity or statistical dispersion. So the higher this is, I believe I'm getting this right, the higher this number, the less similar the data. So Gini coefficient of 1, I may have to look that up. But basically, you can think of the Gini coefficient as a way of determining how different the data is. And there's some other information here. We won't get too deep into this currently, but you can kind of see that it's making a decision here that if the temperature is less than or equal to 84.5, then if that's true, then you move on to the next branch. If it's false, then it kind of drops off and you have a dead node, and it classifies it as no golf. And then if it is less than 84.5, so this is kind of like cutoff of what the model is determined is hot, or the weather is the temperature is too high, so below 84.5, and including 84.5. If that's true, then we ask whether the outlook is overcast, and this less than equals to 0.5. This is basically splitting the decision between the 0 and 1. So this is the model's way of saying if it's less than or equal to 0.5, then that's that's kind of a true. And if it's greater than, or if this is false, then we kind of get our same hung node here. Gustavo asked the CLF train equals CLF.fit. Didn't work for me. Can you paste the error you got, or did it not give you an error? And while you're doing that, I'll kind of continue giving some intuition about this. But as you can see, you kind of go through, you look at the outlook sunny, and the temperature, and you keep going down and down until you have no more leaves left on your tree, and you will be able to navigate this in each case to make a decision of whether you you're not golfing or you are golfing. And you can see that anywhere that there's like a last leaf on the branch, that's where all the decisions are made. So no golf, 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 no golf, and then these up here as well. So gold, oh, okay, so gold underscore DF. So somewhere in your code, it should say golf underscore DF, and it says gold underscore DF. So there's probably a typo somewhere. It should tell you what line that occurs at. And I'll give you a few seconds to update that and see if that fixes it. And if not, I can kind of circle back around at it at the end when we have some time, once the webinar is finished. So basically, the steps of what we've done here is we've created our decision tree classifier, or our empty decision tree classifier. We've stuck that into a variable CLF. Then we train that, and then we output our decision tree. Oops, where did that go? Yeah, there we go. We've outputted our decision tree. And this is kind of just the same thing that we've done here. So sklearn automatically created our decision tree questions for us of whether I play golf when the temperature is over 84.5, and so on and so forth all the way down. And now we can use the decision tree to make predictions. Note that not all decision trees will be the same. We are dealing with some, a pretty small data set here, so it's very unlikely that randomness will have an effect on that, but that is possible. So, it kind of explores and finds the optimal decision tree to provide, and that won't always be the same in every case. Gustavo, was that advice helpful for the typo? Were you able to get that working? All right, I'll follow up with you towards the end. So now that we have our decision tree, let's send it a new piece of prediction data. These will be continuous values for temperature and humidity, and a list of binary values that follow our one hot encoding. Awesome, Gustavo. I'm glad that was able to work for you. It will return our label classifier, which is either yes or no, or in this case, golf or no golf. And then put in a temperature, humidity, and an array of zeros and ones, and see if it properly determines whether you should play golf or not. The input here says that the temperature is 72 degrees. It's 15.3% humidity. The outlook, hold on here, I gotta kind of remember what the zeros and ones meant. The outlook is sunny, and it will be windy. So this is kind of true for sunny and true for windy. And then we'll print our prediction. So again, this will be an opportunity. Let's see here. I don't think this is live code. Yeah. Okay. So kind of see the same data here. We have we're running our prediction. We have our columns here, and then we're creating a variable prediction, and we're assigning that to the value of the output from this code here. So we are taking our trained classifier data, so CLF underscore train. We're using the predict method, and what we're predicting is whether or not we should play golf based on these values here, and then we're returning our prediction. And so in this case, based on the 72 degrees, 15.3% humidity, the sunny outlook, and the windy conditions, it would predict that yes, we should. Some of you may have gotten a different result. Again, it's kind of random, and we'll get into some of the limitations of this model in the next slide or so here. Let's see here. Yep. And so there's also a challenge here. So for added practice and to improve your model, think about what other factors would help make better predictions about whether or not you should golf, and add those to your data frame in the collect the data section. So that would be way up here. So you can kind of add additional data here or change these things around. Again, I highly encourage you to play around with this. If you kind of mess things up and you get an error, that's a great opportunity to learn. One of the bigger challenges for people to learn how to program is you're kind of confronted with your mistakes really frequently. And the best way that I've learned to get over that is to just make a lot of them and familiarize yourself with what errors mean, do some research, And at first that can feel a little tedious, like it slows you down a lot because every time you get an error, you know it's going to be maybe like 10 or 15 or 30 minutes worth of research to figure out what's going on. But what will happen eventually is the more you expose yourself to errors, it'll start to just feel like spell check. You'll get an idea out, you'll code a bunch of lines, you'll run it, and then Python will just tell you where all the errors are. And the more familiar you are with them, the faster you'll be able to say, oh, okay, I know what to do here, I know what to do here. And you just kind of fix them through your code real quick, and you'll be able to get it running a lot faster. So I highly encourage you to play around with this. Maybe grab data from somewhere else and take it slow, see what you can change, see what the outcome is, go through, run everything, and research the errors, and see if you can add some additional data above, and see if you can kind of figure out how to address some of the weaknesses in this model. And of course, the model does have a few weaknesses, so to kind of give you some direction on that, one of the things we have is limited inputs. We only have a handful of categories of data, and we're making a lot of assumptions. We're making a lot of assumptions about that data, right? So for instance, we're assuming that people are going to have the same definition for sunny and overcast. Rainy is a little easier to interpret because it's like, is water falling out of the sky? So it's a little less, ambiguous, but, what could be, too overcast for someone might be just fine, just sunny for someone else. Temperature is a good one. Obviously, being able to have numerical data that kind of grounds it more into data that's like observable, right? We know that like whether you feel 92 is too hot or not, 92 is what it is. Windy, again, this is kind of, we're making assumptions that people have the same meaning for false windy and true windy. So, this might be a good opportunity to add in like wind speed, maybe like miles an hour or kilometers per hour or something like that, rather than true and false. And so again, like with the temperature and humidity, that gives you more concrete data about the state of whether it's windy or not. Those are, kind of some of the weaknesses that we have. And one of the other things is we have very limited rows as well. We only have 14 of these. And, kind of one of the common ways to solve problems in data science is to just get more data. It's like, oh, this isn't clear. It's got a very high R-square score. Maybe we need to get more data. So the more entries you have, the more features you have, typically the better overview of the data you're going to have, the better the predictions you can make. And at the very least, it'll give you enough information to figure out, maybe some attributes are redundant or they heavily correlate with another attribute. You can drop it, and that gets into more complicated aspects of data science, which we do cover in other webinars. So I highly encourage you to check out Thinkful's website to see what those other webinars are. So now we're going to cover some steps you can take to continue learning about data science. Meetups are great. So websites like Eventbrite and meetup.com will give you information about people in your area who are also learning data science, learning Python. And it's great to be able to work with people in person to learn how to code, because you can find that they have maybe similar interests and similar projects. And kind of going into this idea of, painters paint. Data scientists do data science, programmers program, and if you're doing it badly, that's okay, because you're going to do it badly at first, and doing it badly is what's going to allow you to make those mistakes that are going to inform you of how to do it well. So you definitely want to try and program as much as you can. When you run into trouble, or you kind of maybe want to explore a new specific topic, I highly recommend checking out YouTube. There are tons and tons and tons of tutorials. I will give you a piece of advice for YouTube tutorials and tutorials in general, because you can find tutorials elsewhere. Check the date. You want to try and kind of find the most recent ones, because as tutorials age, tons of things change. Versions of the software, versions of the library change, method, like the way things are defined can change. You always kind of want to make sure that you're using the most recent stuff. That's something that kind of slowed me down. I'm a self-taught programmer. And that really slowed me down because I'd follow a tutorial and then I'd be met with nothing but errors that I didn't understand. And it was just like hours and hours of research. Come to find out the tutorial I was using was, several years old. And if I had just followed a newer tutorial, then I wouldn't have had that error. So definitely make sure you're checking the dates on your tutorials. And coding websites, so things like DataQuest are great. They've got some great free curriculum. And let's see here. So hopefully our time today has you feeling a little more excited and confident to continue learning data science and Python. If you have any questions about Thinkful or any of the material we've covered today or data science, I'd love to get into those now before we end the webinar. As you're typing out your questions, I want to provide you some additional information. So while you're thinking about those and typing those up, one of the easiest ways to get your questions answered is to set up some time with our admissions advisors, who are experts in all things Thinkful, and they can answer anything around tuition, enrollment, your local market, and more. I'd also encourage you to enroll in our free 2-week trial. When you sign up for the trial, you gain access to about 100 hours of the actual program curriculum. You get unlimited office hour access, so the sessions that are similar to this webinar format, and lifetime access to our student Slack channels. Combining webinars and the trial is a fantastic way to learn more of the data science skills that we didn't have time to dig into today. I mentioned a couple times that there was stuff that we cover in other webinars, so I highly encourage you to check that out. And I'm going to post some of these links below for you guys. So this is to schedule a call, and this is to fill out an application. And this is a link to the trial. So definitely check those links out, and hopefully you've had some time to think of some questions. So I'll give you guys about 30 to 45 seconds before we wrap the webinar up to do that. And again, just a reminder to let you know, I will be hanging out in chat after we end the webinar for about 10 or 15 minutes to answer any other questions you have or address any errors or anything like that that came up that you didn't want to address during the webinar. And once we end the webinar, as I mentioned before, it'll kind of automatically start a replay. So if you want to sit here and watch through that again, while all these things are kind of fresh in your mind, go through it with a second pass, I recommend that. If not, you will be getting an email link that has a link for you to download the webinar, and a combination of the webinar, the slides, and the coding, the Colab notebook will be a great resource for you to kind of explore these ideas and attempt that extra challenge at the end. So let's see, it'll give you about 30, 45 seconds to come up with any questions, and we'll end the webinar. I really appreciate you guys joining. All right, since you guys didn't have any questions, I'll go ahead and end the webinar. And like I said, I'll be hanging out for about 10 or 15 minutes, so feel free to ask me anything in chat. And thanks again for joining.